Hello everyone, nice. Thanks for joining for this lunch talk. I hope that we will enjoy the salads and others stuff to eat. And I will chat with you about platform engineering today. And especially how we transpose it in context of Doctolib to change the way we are working, and we are changing the architecture at Doctolib. I'm Arnaud Retier. I'm engineering manager at Doctolib for 2 years now. I'm leading the teams responsible of CI, CD, developer experience, quality, release management, all these kind of things that we have in a platform engineering team or department. I have a software engineer background for a long time, and now I switched to the dark side of manager. And I also looked at the production side very frequently. I love the topic of developer experience and the tools that are around it. For years, I contributed a long time ago from Maven, Apache Maven, or Jenkins. This is how I learned a lot about these topics. And today, obviously, I'm a bit older, so spending my time to talk a lot more than doing myself. Obviously, this is the role of manager. Thus, I'm contributing to a podcast, Les Cascodeurs, French podcast, and I'm also leading the call for paper for the DevOps France event. What about you? Who has a good idea of what platform engineering is? Raise your hand, because I don't see a lot. Oh, really few hands up. Okay, and then in these few hands, who thinks that they are in a company applying platform engineering pattern? Okay, really few. Okay, that's good. I hope that we will learn a lot of things today. What we'll see, because I was expecting to not have a lot of knowledge in the audience about platform engineering, I will start by doing a tour of what platform engineering is, where it's coming from especially. It's not coming like this on the table. Thus we'll see a bit the history, what is platform engineering, and then we'll focus on Doctolib to see how we are using this approach to change the way we are working and the architecture we have in our company. Okay, let's start with platform engineering. I told you I was coding for a long time before. Myself, I started my career around 1999. It was a time where the Apache Software Foundation was just created, so that's a long time ago, where we had a project, a top-level project called Jakarta, for the old ones in the room who remember what Jakarta is and is not anymore. Those to have a top-level project for all the Java projects. Now, in the Apache Foundation, you have millions of things in Java. When I started my career, I remember that I was writing applications using GSPs, servlets, struts. I think I used the first version. It was probably not even stable version of struts. And Ant. Yes, Ant was a really good tool before I discovered Maven. And yes, writing application was really different from today. Many things, I listed a few things. We changed a lot the world of software engineers. We changed a lot in 20 years. We changed a lot with the cloud computing. Cloud computing is something which was existing for decades, but which started really to be visible and used by people in 2010, something like this. After the first version of AWS, which was launched early in 2002. The cloud computing is changing a lot of things, because it was the first time where we were able to ask for services, infrastructure, platform, software, on demand. It was a big change in terms of mindset. It was completely changing the way that we were working, where we had very complex processes to, I want to have a server. It was a mess to get a server if you were working 20 years ago. It was a big process to just rack it on your infrastructure, because you were owning all your servers and all these kind of things. Those many changes came from here. The cloud computing adoption, which provided those everything as services, as API, and also the pay-as-you-go, a different model from what we used to have 20 years ago. We were just paying for licenses for a decade or something like this. The second revolution is related to containers. When I said that I was writing applications using servlets and so on, at that time, I was supposed to provide a web archive. I was lucky I didn't use EGB at that time. And my operations team at that time just didn't know what was an application server, a Java application server. Thus, at the end, I had to provide everything. I had to provide Tomcat. I had to provide the documentation to deploy a Tomcat, to maintain a Tomcat in production as a service, and so on and so on and so on. The container appeared with Docker, which make it available to everyone, to masses, and especially to developers in 2013, followed by Kubernetes to try to orchestrate all of that, and the Cloud Native Foundation. It completely changed the way that we are delivering products. Today, we have a unit which is a container. We deploy a container, and it's helping on a lot of topics because it's a better abstraction, highest level abstraction that we had in the past. And obviously, the last one, the most recent, everything related to AI. I won't talk a lot about AI. There are a lot of talks about AI at Doctolib, actually, at DevOps. But yeah, it's completely changing again how we are working, and the tools that we provide, but also the applications that we develop. We now integrate AIs in the application we provide for customers, for example. All these changes over the time change completely the way we work, from client server to cloud native to microservices. Probably, who is using microservices in their company? Okay, many more hands. Probably half of the room. But there is an explosion of technologies compared to 20 years ago where, okay, we had few technologies, Microsoft on one side, Java on the others, and so on and so on. Now we have millions of technologies, depending on the providers, depending on the infrastructure you have access on. And as developer, it's an habit now to rely on them. You just don't want to go back in the past and to have a long process to get access to these technologies. Thus, it's good. We have a better set of features available on demand today, but it's creating a frustration of managing everything on the daily basis. There is a second point, which is also, from my point of view, the source of platform engineering. This is everything related to methodologies, everything related to organization models in companies. Let's back many years ago when I started, the same. We were talking about extreme programming. Extreme programming was one of the first agile mindsets where we were trying to change a bit how we were developing, how we were working. We were talking about creating automated tests. At that time, it was not something common to write automated tests, to have a continuous integration system to try to run everything. Then later came Scrum and others, variants and other things, to try to improve how we are working as a team, how we are deploying a product, how we are managing the product itself. Because at that time, we were still fan of V-models. Who used V-models to deliver products? You remember, with specifications, then I write the code, then I do the QA, then I deploy the product, and then the customer is angry because it's not at all what he wanted to have 6 months or 1 year ago. Those Scrum and other agile methods change that by introducing short cycles to try to have a quick feedback loop between the product owner, the customers, the development teams, and try to have really the product mindset inside the development team. So really think about what the customer wants and how we want to provide the feature for him. Then, it was around 2009, something like this. We got DevOps, a Belgian guy. We introduced the notion of DevOps. He was frustrated by the walls that we created for decades around developers on one side, production people on the other. It was a nightmare, and it's only the first wall. Because it was a ping pong between them. Okay, I want to deploy to production. Did you follow the form, blah, blah, blah? Did you write the doc, wrote the doc, and so on? It was a nightmare. It was a nightmare, not efficient. Everyone was working on its side with his own rules, his own tools. Everything was specific. And then it was a lot of frustration to just try to put something in production. DevOps try to break the silos. Try to break the silos and promote the collaboration as early as possible. Try to put the people together. Let's define together from the start of the project how we will deploy to production, how we will do the QA, how we will handle the security, or these kind of things. And we learned on each side how to work together. It's really interesting because when we were really specialists on software development, at that time we weren't necessarily knowing what was happening on the production side and vice versa. It was really limited, the interface between both worlds. Thus we learned a lot to work together, to improve our methods on each side. On the operation, we try to apply more developer approaches, like writing code and being GitOps oriented. On the developer side, we had this vision of what we want to deploy to production. But to improve all of that, we cannot improve if we don't measure. It's important to measure. Thus, we introduce a lot of measures, a lot of patterns to try to follow how the teams, how the companies were evolving. DORA metrics, space metrics, many, many of them. So here we were in an area where we wanted to change. We wanted to change the way we were working in corporate environments. It's really going further than just changing how teams are working. It's really the whole organization of companies which was changing. Trying to put people working closely together, it's not so easy. But DevOps, it's not so easy if you practice it. Obviously, it's not a tool. So a lot of change. The change management is difficult. It's a mindset. So we have to put everyone all together to try to find the best path to deploy, to create an application, deploy it to production. There is also this shift left mindset. Shift left is this mindset of, okay, let's start from the beginning to introduce everything related to QA, to quality, to testing, and so on. But it was really badly implemented in many companies. How many companies I saw where, okay, we just asked to the teams, okay, now you were developer teams, now you will also do production, you will do on-calls, you will do QA, you will do, but you are the same team. Yes. It's completely crazy because we don't want to have 5-legged ships in teams. It doesn't work. It's not scalable and it's just impossible to have. So this kind of models failed a lot because we were just rebranding teams, giving them more things to do, but not providing them the infrastructure or the processes, everything they need to do it efficiently. So giving them the autonomy is good, but also when it was implemented, there was another side effect, is that some teams, some companies, forgot to try to centralize, to continue to centralize the knowledge and to try to unify it. So it's also difficult because if you start to say, okay, all teams are now autonomous, they can go quickly to production, we provide them everything they do, we just give them the credit card, they plug it to the AWS account and YOLO, you do everything you want. Firstly, good luck for the credit card. But then, it's a mess. It's a mess quickly because everyone will use a different data warehouse, a different data store, a different... There are so many services. So if you don't continue this effort to try to centralize the knowledge, to try to unify a bit all of that, it's going in many directions and probably not the direction you would like to go. So you build it, you run it, yes, but you need the right structure to support this philosophy, and this is what platform engineering comes to fix. Those platform engineering is based on this concept. Product teams, those are the ones who are developing the real product for your customers, should not need to be expert on everything. It's good to make them autonomous. They should be able to manage everything, but don't expect from them to be expert on Terraform, AWS, and writing front-end code, and back-end code, and also the database. And are accepted if you create teams of 20 people, and then you have other problem of scalability. It doesn't work. Platform engineering is focusing on providing self-service features. So you try to reproduce what we have externally with cloud providers, with platform, or this kind of platforms where, okay, you need that, you just click somewhere, you launch an API, and you have it. So we try to automate as much things as we can to be sure that we are not a blocker. And we want to empower them. And so the most important thing is that it's also a product-focused discipline. We are building a platform. The platform is a product. It needs to be thought, we need to thought about it as a product. The key principles, self-service and automation, nothing really new. We are doing that now for decades to try to automate things as much as possible when it's useful. We try to avoid manual tasks. We try to automate recurring ones. But with a self-service mindset, because if for each task you just need people on your side to do something, you just don't scale. When you have 20 teams around you and you have a small team to just create a repository there or deploy this stuff, it doesn't work. So you don't want to be on that path. Product mindset, because the platform itself will be your platform. It's completely specific to your business, to your activity, to your constraints. All companies are different. We don't have the same technology stack. We don't have the same people. We don't have the same product to build and so on. Thus, you must think it as a real product. You have to provide everything as a product. Thus, you have to think like if you were producing it for external customers. For external customers, if you provide a product, you will provide a documentation, you will provide a service team, you will provide consulting, whatever. It is the same. But the customers are a bit different. These are your teammates in the same company. Thus, the wall is really less high. It's really better to communicate and to work with people who have exactly the same mindset than you. They have exactly the same skills. Thus, you are talking to the same people than you. Developers, data analysts, operations people, SREs. Thus, it's a good opportunity to build something also together. It's important to try to create a platform for them, but with them, with these teams that you try to help and to embrace. Sorry, wrong button. So what are the benefits? The benefits, we see three main benefits. We try to increase the productivity, the velocity of the product teams, with faster deployments, with everything available as a service. We try to shorten the feedback loops, and we try to provide more innovations for them. We try to obviously improve the reliability and the stability. When we talk about a platform, we talk about the runtime platform, the CI platform. We talk about the whole chain of delivery. So obviously, we want to have something which is stable, which is robust, evolving efficiently over the time. And we enhance the collaboration, because this platform should be where people are collaborating, all the different kind of profiles. But obviously, there are challenges. I won't lie. It's not so easy. There are many risks. When you try to build a platform, obviously, you will try to do too many things. A platform can be complex, could support a lot of things, a lot of needs. It's not possible. It's never possible to reply to all the needs from the teams. like for your customers. You have customers in front of you, they have always more requests than what you can provide. This is the same for the platform teams. Thus, you have to choose your battles. You have to be sure that you focus on the highest value for the whole, all the teams that you are in front of you. Define clearly the rules, the frontiers, the borders you have between the platform and what the teams are doing. It's important because if something is blurry, you will never be, they won't be confident to do things because they don't know if it's them, if it's you. So you have to take care that it's clear for everyone where is starting the platform, where it's ending the platform. What is under the responsibility of the platform engineering team? What is under the responsibility of the development team? Especially if you succeed one day, I don't know if it's your case, but if you succeed one day to really delegate the whole production to these feature teams, the day that they are able to manage on-calls for you, that you don't have any more on-calls. You have on-calls for your platform, but teams are responsible of on-calls for their products. And you don't want to do their on-calls, obviously. As I said it earlier, you don't want to be the bottleneck. So you have to take care to find your place and to be sure that for everything you provide, you are not on the path for using it. And then the biggest, the complex part of the work is make or buy. It's not new. It's something that we have every day for decades, but it's always difficult to choose between doing yourself and buying something. Buying something with all the risk of locking and this kind of stuff. Obviously, the platform should contain the minimum number of components to provide the larger number of features. So it's important to try to find the right trade-off about what you put in the platform, what you do yourself, and you will have to maintain what you buy outside and so on. Okay, now let's talk about my context at Doctolib, because the idea was to share what we do at Doctolib and how we use this to try to change the way we are working. So Doctolib, in 2 seconds, we are working on healthcare communities. For professionals, we provide services for doctors and professionals in healthcare to help them in their daily activity. And then we try to help everyone by giving everyone an access to care. The tech team at Doctolib, we are talking about 800 people, a bit more today. As you can see, we have at the top all the products streams. So we are working and we are providing products related to clinical, financial topics and so on. Don't ask me details, I'm just a tech guy. In the common platform. In the common platform, we have a lot of things with these common platforms that we'll talk about just after, but we have with us, security guys, data and AI. At Doctolib, we decided to have different streams for these 3 activities. There are companies where everything is together. There are some companies where it's more fragmented. So, up to you. On our side, we decided to keep the security aside and the data and AI aside. The technical stack that we use at Doctolib, historically, we have a Ruby on Rails application. Big Ruby on Rails application with a front end written in TypeScript. And recently, we are introducing some Java and Kotlin code and services. Not my fault, but I'm happy about it. We have obviously some Python, as we have some AI features, and many more things. We have a big challenge. We have a big challenge because we are a 10 years old company. And we have a big monolith. A big monolith, 2.5 million lines of code. In theory, it's manageable, but it's not so easy. It's a very basic architecture, a monolith with a big database in backend. Okay, the largest database in Europe for AWS, but it's another story. But we have some pain points. Some pain points is because, obviously, if we have a large code base, what is good is that we have a lot of automated tests. We today have more than 90,000 automated tests. That's a lot. That's a lot. To give you an idea, if we execute them all one by one, This is, in average, 90 hours or 100 hours of processing to run everything. And we run everything on every master, on every commit, which is going on the main branch. We have 20% of end-to-end tests. End-to-end tests are awesome because you just replicate the end user behavior, and it's good to validate that everything is working well, especially in a monolith. It's easier because if you don't have a lot of external systems, you can easily reproduce your monolith environments, database, the backend, the front end, easily, and you can write this end-to-end test. The problem with end-to-end test, it's classical. They are known to be flaky. It's hard to write end-to-end test. It's easy to write them, in fact, but it's really hard to maintain them because things are quickly changing and the pop-up is not at the right place and so on and so on. Those writing good end-to-end tests is hard, and then managing the flakiness is difficult. Feedback loop duration and obviously the cost of managing all of that are not helping much because yes, 90,000 tests, that requires a lot of CPU to process all of that and a lot of time. Maintaining also the branch, the main branch green, when you have more than 70 teams working together on the monolith is not so easy. You can try to add a lot of blockers at the pull request level to be sure that everything is validated, but you still have conflicts. You still have things which are happening that you don't really anticipate. Why? Because on the monolith today, we probably have 150, 170 commits per day. Those every few minutes, because we are working on European time zones, so you have one commit every 2 minutes. So when you have a feedback loop which is taking 40 or 30, it's difficult to verify that everything is okay. And there are some also technical limitations. Having a monolith is good. Honestly, it's scaling well. There is no problem of scaling the monolith. It's easy to scale a monolith, add more pods on Kubernetes and so on. It's working well. But now there are some constraints. Having only one delivery unit means that everything is at the same level when you do a compliance check, when you do some certifications. So if you have different features of different levels, some of them are critical, and you can imagine that in healthcare management, you have a lot of compliance rules, you have a lot of things to take care in terms of security, privacy, and so on. The whole product has to follow the same rules. Thus, it's not necessarily the most efficient to ask for every feature to reach the same level of compliance. Thus, we decided a year ago to move to multi-services. We're not saying microservices. Not yet. I hope not too soon. The idea is to have some monoliths, at least around, to be sure that we can segregate, we can better manage the code base and the features. We want to improve, obviously, everything related to the developer experience and the efficiency, shorter feedback loops, a smaller code base, and so on. We want to be able to rebuild some part of the product, because after 10 years, obviously, there are some parts that you want to rebuild. We want to follow better patterns in terms of developments. 10 years ago and today, there are a lot of things which changed. So now we would love to do some DDD or these kind of things. It's easy when you start from scratch. If you want to refactor 2.5 million lines of code, it's more difficult. We want to adopt new technologies, just because Java is cool. Yes, we love it. Kotlin also. And we want to improve the deployment strategy to have something which is smoother. But we have challenges, obviously. If you move from monolith, the advantage is that it has a lot of advantages, but you have obviously some constraints when you move to multi-services. You will want to keep a unified customer experience. If you have one app, everything is done the same in the app and so on. Okay, everything should be unified. If you have different apps, different parts of the apps, you have to take care of that. We have to provide all the tools, all the automation, everything that we were doing for the Rails environment, for the monolith. We have to do it for different languages, different platforms. We have to ensure the compatibility between services. When you have a monolith, the compatibility is done automatically with all the tests you run on the monolith and so on. But if you do it with multiple services, you may have incompatibilities, and then the platform is broken. And you want to have a different deployment strategy. When you have a monolith, okay, you deploy one unit and it's all done. If you have different services, you will want to share that, to manage that more smoothly. Thus, at Doctolib, we created, it was before I joined, it was 4 years ago, was the creation of a platform engineering team. Thus we call it PEER, for Platform Engineering Enablement and Reliability, where we have 3 different streams. We have a platform stream where we provide reusable components, where we provide templates, scaffolding, all these kind of things. Those really people who are working as developers for the different teams, the different product teams, to try to centralize, share code, try to better manage that. We have the engineering enablement team. I talked about it. This is what I'm leading, just trying to automate as much things as we can, try to manage the quality, try to manage the metrics, try to improve the developer experience, and everything related to the runtime platform, so the reliability with SREs. We propose a runtime platform with different services and maintain it. Today, we built in few years a lot of things. So we have this production platform, which is mainly on Kubernetes, but with various backends for databases and so on. With classical features, we'll say, nowadays, monitoring, observability, logs management, errors management, all these kind of things. We have all the CI and CD systems to try to automate as much things as we can, up to the deployment. Today, the monolith, every teams we have in the company are able to deploy it at any time if they need, if there is an outage or whatever they want. But by default, we deploy it 3 times per day. So it's completely transparent, but 3 times per day we deploy it. We have all the development toolbox, but it's really oriented to the Rails needs and to the monolith needs. So we have in early adoption a backstage environment for providing a unique data source for the different services we have. We have a quality metric platform, today SonarCube, but we have a lot of in-house stuff. Because to manage this 90K test, it's not something that you do usually on GitHub Actions. We use GitHub Actions for running the CI. But running 90K test on GitHub Actions, it's a bit difficult. Thus, we have a custom testing infrastructure that we pop up to handle the 90K test. And we are able to execute them in 15 minutes instead of 90 hours. We have a test selection system, because running all the 90K tests every time is maybe not the most efficient and not what is the less expensive. Thus, we have that, especially for the pull request. We have ephemeral environments to allow developers to test in their pull request what they are working on, and thus to have a mini deployment of the application. And various shared components, a design system, feature flag management, authentication, authorization. But all of this really targeting the monolith. Thus, in this move, the main move is a cultural change. And it's not something which is technical, but we have to work differently with teams, us, the platform team. In the past, we were able to provide a lot of services through the monolith. When you have a unique code base, you add something there or something here, and hop, that's done. It's available. Oh, the new logging mechanism. Oh, the new monitoring. It's done. It's indeed. When you have now 20 services or more, you cannot do that. You have to propose a service to do it. You have to propose a documentation. You have to propose everything to let the teams do it. Otherwise, you don't scale. So it's a different abstraction, a different interface that you have to set up with these teams. You cannot do any shortcut. In the past, we were doing a lot of shortcuts because we had access to the unique code base. It was easy. And the knowledge is not centralized enough. When you are in the same repository, it's easy to share the knowledge through the code base. When you have 20 or more repositories, not the same thing. So you have to change completely how you are communicating. And then, yes, we need to learn the teams to work differently. They need to be autonomous. We have to stop to do things for them. We have to really provide a platform. So it's a big, big change in terms of mindset when you worked for 10 years in a monolith. We have to update the platform itself. So we have to Update the monitoring and observability to allow to manage the traceability across services. It's easy when you have a monolith, you can trace everything from the end users to the database. When you have multiple services, it's another story, context and so on. We have to share some features. We have to potentially extract them from the monolith and so on, feature flag, design system, and so on. We have to change the release deployment because the release deployment, which is 3 days per day for the monoliths, doesn't make any sense for new services. Some of them will need only one release, few days, few weeks per week. Some others will just be continuous deployment. We don't know, but we have to work with them to understand what they need and to adapt it, because what was done for the monolith is clearly not what they will need for the new features. And we need new features. We need new features, scaffolding, to initiate and start the projects more quickly. We need scorecards and maturity models, because today we have a lot of monitoring on the monolith to understand what is inside the code base, how it's acting, what is the quality of the code base in general in the monolith. Tomorrow, with 10, 20 services or more, no, we need to provide them a way to look at their code, to be sure that they understand what is the maturity of their product compared to the others. We have to provide new solutions in terms of testing, for example, to manage integration tests. We choose to deploy Pact, for example, to handle integration tests, contract testing. We have to exchange binaries and shared components. It's something that we didn't need. When you have a repository, a unique repository, everything is at the same place. You don't really need to share components and share code. Now we need to put a repository manager and so on. Those are the conclusion. Internal platforms, as we can see, are not really new. It's just the continuation of what we did for decades. We just move the mindset to manage them as products. Thus, we have our customers, it's clear who we have in front of us, and we work with them to build the platform. It's a good opportunity to work with them because we are really close to these customers. We are in the same company, we work together. There are many interesting stuff to do for having an internal platform. We will reduce the cognitive load of teams. We will improve the product reliability and resilience. We will accelerate the development of and delivery. We will reduce the security and regulatory, hard to say, and functional risk. And we will enable cost-effective use of all services because it remains an important point. Your budget is not unlimited, and you have to allow teams to understand what they consume and what they do. Platform engineering is a discipline. It can be implemented with platform teams, as we do, but it's not necessary. There are some companies who don't have platform teams, but this is a contribution from everyone, and so on and so on. There is no magical solution, but you need to think about the product you want to build together, and you will try to apply all the best practices that you get from the different people you work with. That's all. I don't know because the timer is broken, so I don't know if I am on time or late. 2020, I think that it's over because I was said that the room will be really crowded in a few minutes. So I will stop here. I will be outside if you have any questions. Thanks a lot for attending and joining during the launch this session. Have a good day.
All systems are nominal. Initialize Genesis sequence.